So my name is Omolai Pinsami. So I'll just quickly show this ETL project tutorial on how you can connect to your Microsoft SQL server and then move data from one database into another database in progress, while you can make some transformations on your Jupyter Notebook. This is good for if you're doing data analysis jobs or data science jobs, and then you have to use Jupyter Notebook to maybe carry out modeling, modify the data, transform the data before you load it into your progress or anything. But just a simple tutorial. So this is my Microsoft SQL Studio. As you can see, I have a database here called AdventureWorks 2022, and these are the tables under it. These are some of the tables under it. So for ease of use, I'll just be working with just few of the tables, yeah, not everything. And then I have created a user here called ETL, and with a particular password and username. So the user is ETL, and then the password is, I won't tell you because that's my password for the database. So you can easily create an SQL database with just the same name. I mean, this, okay, you download this and you just load it. So it's very easy to actually load this. When you go to database, you can do new database, you can restore database from file and get after you have downloaded it. So but and also this is my Postgres server, PG admin, and if you look at it, I have the same database AdventureWorks. So I created this myself. It's also easy. There's a video on how you can just quickly create a Progress database. It's just about 4 lines of code. When you create it, you also do the same thing here. It's also do the same thing. You create a user, call ETL, and you use, let me show you the tables. Yeah, these are the, okay, so they are not supposed to be tables here, except not move them just because I've done the project before. So I have, these are the tables that I moved, but you will still be seeing them. In this tutorial I'll be moving, I'll be changing some of these names to new tables so that you see how effective it has been. So if you go to login groups, you see the user that I created, ETL, with actually use the same password. You can use different password. So that's the preliminary setup. So and now if you go to my working directory, I have this file called what is it, dbs, yes. So I have this file called config. So this config is just a simple Python file where I save my password and username. You can do that so that you don't have to write your password and username out there, and that's it. So let's go to our working environment. I'm going to be doing this whole ETL process using Jupyter Notebook because it's a very good environment for data analysts, data scientists, and all. So first of all, we're going to import the modules that we need. One of these modules is called PyODBC. PyODBC is an engine where that you can use to connect your SQL server to Python. And then, of course, we are going to be using pandas for data transformation because it's an ETL project. The transformation aspect of it is going to basically be done with pandas and some other libraries that maybe we might be needing. That's pretty. So hence, now I'm going to use SQL Alchemy. I'm going to use SQL Alchemy create engine, and then I'm also going to be using a module. This is going to be used to when I put in my credentials, it's going to be used to form a URL that I can connect my Microsoft SQL server to my Python environment with it. So let me import it. Go ahead and import this module. So fast, they already imported. So Now I'm going to set up my connection string. I'm going to set up my connection string now. You're going to follow the syntax exactly here, if not it's not going to work. So we're going to specify the driver we want to use. Now if you want to look at the ones that you have, you can do biodbc dot drivers. Sorry, I think something is missing. biodbc dot drivers. Yeah, so these are the list of drivers that I have. Just copy this name exactly the way it is here. I'm using 17 for this project. There is a tutorial also on how you can download these servers in case you don't have any of them, and it's very easy. You put it in a curly bracket, and then you put this. Don't forget to put this semicolon, and then you close the double quote. So then after specifying the driver, you also have to specify the server, also everything in code. So our server is just our, so let's look at our Microsoft SQL server. So you can see it's SQLSS. So this is my root, or this is my local host, or I can just simply use my system name there also. So anyone, I can use localhost address or use my system name, so as it's going to be my root. So let me go ahead and use my system name. So this is my server, and then I'm going to specify the data set I'm going to be moving my data from, or I'm going to be connecting to the database that I'm going to be connecting to. So the database I'll be connecting to, like I said, is the AdventureWorks. Get the spellings right. AdventureWorks 2022. So I'm going to write it here. AdventureWorks 2022. So that is my, don't forget the semicolon, the colon or semicolon. So then I'm going to go ahead and specify my user ID. I told you my user ID was ETL, that I create a user called ETL. Fine, I could just write it here. Of course, you already know my user ID is ETL, but again, like I said, I created a password for a file called config, so I'm going to import the file now. It has my username and there, so I'm going to go ahead and import config. This is a Python file that I created for my password, and then it's imported, so I have them already. Now I don't have to type it out here, so I can just use fstring. So the next thing you have to do then is to specify the connection as trusted. Just construct connection is equal to yes, that's all. And then that's it, connection string is set. You can have it like this, and confirm everything is fine. Yeah, I can run it. So I have my connection string. So this is how you now connect to our SQL server using this connection string. So you're going to create a URL using our URL. Using the URL library, I'm going to create a URL, so it's going to be URL. This is URL.create. So first of all, we're going to specify the engine that we'll be using. we're going to be using MS SQL, Microsoft SQL plus BioDBC. This is the engine we'll be using, and then again we'll also be specifying what our query will be for the connection. So our query is the connection string. Now it's saved into a variable called saved into ODBC connect, and then value is our connection string. There you go. So that's it. That's our connection URL. After specifying the connection URL now with the engine, so all we have to do is to create the engine. So our source engine, or SRC engine, will be equal to the create engine. We're going to be using the create engine module, create engine, and we're going to be putting our connection URL. You can actually complete this whole thing in a single line, but I prefer everything to be neat and spelled out like this. So this is in capital letters, URL. Then now we're going to be creating, after creating the engine, we're going to create our source connection now that we are connecting to our database with, to our Python environment. So it's source engine dot connect. Again, you can also do this here and put the dot and put everything and put everything together in this line. So, but I like to spread it everything out like this. Now we can run this code and see if we are able to connect to our database successfully. Create is not defined. Sorry, it's create engine. Where's it? Create engine. Sorry. Okay, we're having an error. Trusted connection. Invalid value. Trusted connection takes value yes. It's supposed to take value. Yeah. SQL and spaces. So let me remove the space and yeah, so it works now. So SQL and spaces, you need to be very careful with spaces. It sees everything as part of the whole query. So now that we have made a connection, we're going to try it out and see if the connection works. So for example, let's do a simple query. Let's create a simple query. Let the query be select star from look at one of the tables. Okay, let's do sales.customer. So let's start from sales.customer. From sales.customer. So now we're going to create a sales data frame from it, because we're going to have it as a data frame back. bd.read SQL to read it as to read our query as a pandas data frame. So we'll put our query, this query here, and then we specify the connection that we're going to use. This is the connection that we created, SRC con. So let's see if it works. Okay, so let's look at the sales DF. Yeah, there you go. So we have our data, our table here, now in a Python environment. So everything you want to do from here on, you can go ahead and do. You can analyze this table, you can carry out data modeling, you can do a lot of things. And this is a part where you can actually transform any table that you want to transform. Maybe join another table to it, carry on modeling, and then carry out machine learning modeling and add a rule for predicted values and everything. Do all these things, and then when you're done, you can actually save and load back into your database. But in this case, we will be loading into, because it's an ETL project, we're going to be transferring this data into our Postgres server. So now that this is done, all we need to do now is to create a function or a system that can help us load this data set into Postgres. But first of all, we need to be able to connect to, this connection that we created here is for the Postgres. It's for the Microsoft SQL servers. Now we need to connect to the Postgres. So yeah, that's what we'll be doing next. But before that, I want to create a data frame. I want to look at all the tables that are inside this particular database. I want to look at all the tables, their table name, their schema name, and everything. So we'll go. I'm going to create into df1. Now there is a function in SQL that you can use if you have a query like this. For example, let's call it query 1 because we have another query. You can select, schema name. You can select schema name from the system table. Let's call our system table system.tables. There's what they call system.tables that list all your tables. And I look at the F1. So here we have all our 70 tables here. Schema name, table name, everything is there. So now I can select from here the tables that I want to move into my Postgres. So I might not want to move everything. I might just want to move you, and because of for this purpose of this project, we might not be moving everything. So now this is what you can use to do it. But again, you know that when I made this query here, where I did from sales customer, the table name itself is customer, but the schema name is sales. So if you're going to be referencing a table that will be sent to be uploaded into Postgres, you have to also reference the schema name like this: sales.customer, like schema name.table name. Now, in order to do that, we need to have we need to write a code that can actually bring the two of them together like that. So sales, for example, sales.person credit card, person.person phone. So there are different ways to do it. I could actually include it here. Use a concat ws to bring them into another column here. I could do that, or I could do that when I'm loading. So let me continue first. So like I said, now I want to load them. I want to create a function to load this database into my Postgres. So first of all, this is how you can create a Postgres engine. Localhost 5432. Now this 5432 is the default port for Postgres. When you are installing your Postgres, you're going to get it there. 5432 is going to actually bring it up for you to use it. Right? This presentation should have not been. Why did I close it here? That's serious. So yeah, there we go. Our progress engine is created. Now, if I want to move the table one by one, like I said, for example, let's say this table now I have this particular table that I have here. I've transformed it. Let's say I do sales df the drop now. And let's say we don't need the let's say we don't actually need let's say we don't need the account number again. Just say it's more unlikely, highly unlikely that you don't need the account number. As an example, the drop account number, as a spell account number, and then specify the axis is equal to 1, in place is equal to 2. You do this, it's drop. So when you do sales df, it doesn't have account number again. And let's say I want to move it back. As I've removed it, I've transformed the table now. Let me drop it into my Postgres. So all I have to do is this, just this line of code, df dot to SQL. Now, all that I have to do is sales df dot to SQL, and then I specify. So I'm going to save it as a staging table first. I'm going to put it there as a staging table. So let me call it customer sales transform. Is it customer SQL or sales customer? I think it's sales. Let me see how it's sales customer. So I can call it sales dot customer transformed. So that's the name of the table, and then that's the name of the table, and then I specify my engine, which is this engine that I created, this progress engine that I created. And then again I'll go ahead and say if this table already exists, if it already exists, I replace, then index is equal to false. Wait, this should have been closed a long time ago. Sorry. So this is just to append the staging to the names to specify that it's a staging table. So this is all that I need to do this. So if I run this, it's done. So let's go to our progress hour. You see, let's look at all the tables that we have. Schemas, make sure database, schemas, tables. It's not here. So now we have 10 tables. So you see, it says those customer transformed, and if you look at it, you see there's no account number. So this is how you can transform and then save. This is where you can transform data and then move it to data and load it to another database. So this is it for just one table, for any table that you transform or anything. So if you want to move all the table, all you can just do is the engine has been created already, Yeah, so what you can do is wrap it up in a for loop. So like I said, we need the name of this. So you can say for name this is the F1 for name, or for schema name in zip the F1 schema name the F1 schema name you can do and then the F1 table name. So what I'm just trying to do with this line of code, why do I have this too? For example, I could do this print schema plus dot plus name, so that everything can be in this format, schema dot customer. So if you do this now, something is wrong. Okay, so we have everything like sales or store, sales or photo. So for this, so you can do you can make it table is equal to this, table is equal to this. So your engine is already there, engine is equal to engine, or you don't even need to do that, you can do df. So this is exactly the way this is. Our engine is already defined outside. Yes, saves the f dot. But first we have to actually define our data frame data. So this is it. When the first read it out. So the same thing, our query is still going to be, let's write here, select star from after I put inside this, select star from table this time, and then we specify the SRC connection that I want to use. So this is going to be our df now. So the name here is going to be the table, engine if exists, so engine the same thing. So if you run this now, all these tables, everything is going to move to our Postgres server. So but you might not want to do everything. I don't want to run everything to move everything right now. We might just want to use only few of this. Let's say this. Okay, let's just say this is what we want to use. Let's call this list 1. You can do if table in list 1. And run this. Okay, so it works now. So one of them is replaced. So if you look at all the tables that we have here, it says those pressing credit card, see, this is an easy, this, you see how it's flowing in Jupyter environment. You can do a lot of things with it. You can do your modeling, like I said. This is a simple ETL project, and I hope you understand. If there's any issue, you can just quickly drop a comment. I'll work on it. Thank you very much. Thank you.